My name is Shifu Wang. I'm a senior data scientist from the Trade Desk. I mostly work with our company's contextual engineering team, which is why my work is usually about NLP analysis, research, and production. Really happy to be here to showcase TDD, to showcase the partnership collaboration between TDD and Databricks. Really happy to see some old friends from Databricks and new faces here. Hopefully after today's talk, you guys can have a better understanding of what TDD does, how working with Databricks can dramatically improve your company's production, especially if you work with someone as smart as Mark here.
That's quite an introduction there in that case. Hi, folks. My name is Mark Lee. I'm a senior specialist solutions architect at Databricks. I've been working with Trade Desk for quite some time, since about 2021. I find that our particular goals of what Trade Desk wants to do with the entire world and how they want to expand very much aligns with our lakehouse approaches. So in my previous life, I actually was a chemist. I always like to go into this very long spiel. I used to be a chemist, and after about 10 years of work in the healthcare industry, I decided to transfer over and go a little bit to the dark side and find exactly what's going on in the data space. So over at Databricks, we've actually worked with a lot of customers like Shufu and Trade Desk in order to figure out how we can scale out their existing systems and how it can really help them achieve the business values they're looking for. In this case, we're going to talk a bit about how we're building out models to help improve ad revenue for the Trade Desk itself.
Yeah. So first thing first, who are we? Who is the Trade Desk? So we're the world's largest independent DSP. Demand-side platform. So for folks who are working in ad tech or who work with ad tech, you are probably familiar with this term, DSP, but for most of us, probably this is a new term for us. So what is a DSP? I think most of us are familiar with some online brokerage platform. In the US, we have E-Trade, we have TD Ameritrade, or like my former employer, JP Morgan, who are also allowing their customers to do stock purchase now. So different from these cases, we don't buy stocks on Databricks. We help our customers buy ads opportunities out there. And how does this work then? So suppose we go to a web page. At that very moment, the content of the web page just starts to load. And at that very moment, in that very short period of time, all these brands, all these advertisers start to bid for that as opportunity to serve their ads to the consumers, to the audience. And that's where DSP, like TDD, comes in. We help our clients, brands, advertisers, find premium content, find the relevant audience, and we help them decide whether they want to bid on this kind of as opportunity, and if we do want to bid, how much we want to bid. Like I said, we are we're the largest independent DSP. As a matter of fact, we handle more than actually 1 trillion ad opportunities a day. And we work with more than 80% of the major retailers in the US. And we're proud to be the largest CTV content, CTV inventory in this industry, if not the largest one. Yeah, and we have been, like Mark said, we have been working with Databricks to enhance our research, development, and other.
So the partnership actually did begin in 2021, and we were working with the Trade Desk. We were specifically looking at a lot of the transformation logic that was required in order to basically clean data so they could use that to feed into their demand-side platform. As Shifu was stating, the point about demand-side platforms is basically it's a bidding advertising architecture. And the main goal is to find out what is the optimal price associated with a particular advertisement for any of Trade Desk clients, for any of their brands in this case. And very importantly, how to actually increase the conversion rates. So that looks like a transformation process, and that absolutely is an ETL part. And what we did was focus actually on migrating these kinds of ETL workloads onto a Databricks platform from the legacy systems. But along the way, a new use case came about. And it was the understanding that not only are we trying to do better than what we were doing at that time, right then, we also actually wanted to advance the systems at the trade desk to start supporting more into their global vision at this point, which basically indicated the trade desk really wanted to expand to different countries. They are a global organization. So the question is not only how do we optimize the existing workloads to work very well in the current countries, but how do we actually reduce the time to market as the trade desk expands into other emerging economies? So that's when we begin to look at the data science products that Databricks actually provides. And we worked hand in hand with the trade desk in this case to actually look at how we can leverage more NLP research and more NLP models in order to help drive that kind of consumption and also drive that growth for the trade desk itself.
Yeah, so like Mark said, we wanted to do more research, want to provide more contextual related products. So why is the case? Why DSPs like TDD, we would like to provide this kind of products? There was this research that indicated if the medium content and the ads content are relevant, meaning, for instance, if on a sports website, we show an ads from Nike, the neural engagement increases by 43%. And if you show the audience the ads, afterwards, you ask them what the content is on that ads. The relevant ads, they get recalled 2-fold more often than the irrelevant ads. And also 70% of the consumers are more likely to interact with a relevant ads. So for instance, if you display a Mazda ads on kbb.com, it's very likely that these customers are interested in buying a car, and they're more likely to interact with that ads by clicking it. This is why at TDD, we would like to classify the media content into some very detailed categories. In this case, we follow IAB's taxonomy, and we classify the websites, apps, and CTV content into about 650 categories. Like I said, if you land on the KBB website's front page, our model will indicate that it is very likely that this page is just automotive. However, if you dive deeper and deeper into a crossover-related page, our model will indicate that this is not only automotive, it is a car, there's a specific body type, and then there is also this very specific one, which is crossover. And I do want to emphasize again, at the TDD, we do not only classify web pages. We do the contextual analysis for apps and for connected TV, CTV. Like Mark said, we're trying to be a global company. We started from Ventura, California, years ago. But over the years, TDD has grown into a global company. We do not only help our customers, in this case, advertisers, brands, bid for ads opportunities on English media. We also help our advertisers bid on, for instance, German medium, Spanish medium, and on Chinese medium. As a matter of fact, we right now operate in the top 200 worldwide advertising market, and we have many offices that help local business. And the spend on our platform, if we break it down, 90% of them is in North America, Canada, US, Mexico, and 10% of them is outside this region. So this means what? This means there's a huge potential for us to further develop our business in those local markets.
Absolutely, and you really think about it, what we see here is that while the TD itself is very North American focused right now, that actually doesn't reflect the global economy itself. So 33% of all ad dollars right now in the entire world are spent within North America, but 67% are spent around the world. So if TDD wants to actually expand globally and to get other sources of revenue, it makes a lot more sense to understand how we can expand into other sections of the world. And that's where the Databricks TDD partnership is quite strong. So we began to look at what are the challenges associated with actually expanding out to these different countries. And we found that we could actually list it out into several challenges. One, as Sufi was talking about quite extensively, contextual analysis is actually really important. Now, if you think about in the North American market itself, even traveling from different countries or different states, you'll see very large differences in contextual analysis. Now, if you're selling a particular car, I think that's the example that we keep going through. If you're selling a particular Ford car, there are actually different models of Ford cars available in, say, Mexico versus the United States. You need to have that level of context in order to figure out how to basically build recommendations and help optimize customer spend in order to get more conversions. Now, once we start expanding out, we encounter a different problem. If we are actually working within the United States and Canada and some regions of Mexico, we actually speak mostly one single language. In the case of Mexico, we will speak Spanish. But what this really means is that the TD have been operating for some time, understanding very specifically how to actually build pricing models for a certain language, and what we want to do is expand this out to build pricing models for other languages. Yeah. If you really think about it, once you want to get that 67% of all ad dollars spent outside of North America, which is very substantial, more than the actual ad spend right now within North America, we need to understand how to build context from other countries, other cultures, and very importantly, other languages. So we know that there's pricing benefits from this analysis. We know that these particular advertisements that are being sold in these other markets, the 67% of ad spend, actually are in different languages. And we know that we're also processing 1 trillion ad impressions per day, and we also know that the pricing will benefit from fresh data. So what we want to do is we want to build out a pipeline, a system, in which case we can actually get advertisements, web pages coming in to the Trade Desk's own Lakehouse platform. We want to be able to convert those into something that we can understand, get context from that, even in a way that crosses across language barriers in this case. And very importantly, we want to feed that into the ad platform itself in order to figure out pricing for advertisements. So what TDD did is they worked with Databricks and used our extensive industry experience to figure out what exactly would this kind of modernized architecture look like as we're trying to move into other worlds. Well, other countries in the world in this case. If we can see here actually what is our reference advertisement architecture for Databricks. This is what we call the ads lakehouse. Major components of this include different sections like how we actually ingest from different sources. Google Ads, Meta Ads, NetBase, web apps, Salesforce, all sorts of different sources of data will come in, and there's going to be a data ingestion engine that will actually process and transform that data. Well, we'll actually ingest it and move it into what's called a medallion architecture. So in this case, TDD was going to use Databricks, but you can see there's other ones such as Segment and Twilio are also extensively used. Once that data actually comes in, it needs to be added into a particular section that can eventually surface that data in order to really deliver the real value that TDD is looking for from their data sets themselves. And these are what we call data products. Now, I know when you've attended a lot of talks right now within the Data AI Summit, we've been talking about Lakehouse, 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 Lakehouse IQ. Everything's all about the Lakehouse. We understand the Lakehouse is extremely important. We built it. But what's actually really important to us is that the Lakehouse is only a component of many of our customers' different architectures. So when I show you this ads lakehouse right now, it's actually a smaller component of all of the Trade Desk. And what's really important is, as small as that component might look, its benefits for the Trade Desk are absolutely massive. So for example, we pull in that data now. We're going to look at click-throughs, impressions, conversions, things that we generally see within demand-side platforms and attributions, and also very importantly, customer feedback. Because the Trade Desk will want to understand whether or not customers believe the recommendations they provided are valid, and whether or not the advertising pricing models are working well. And very importantly, we are in the modern 2023 now. They utilize machine learning processes in order to actually process that data. We do things like personalization. So we look at a lot of different features associated with each particular user in a particular region. We recommend things based off what particular advertisements would make sense. Maybe there's changes they can make to their advertisements that would actually reach out to their target consumers. We look at, very importantly, campaign forecasts. In the end, the Trade Desk itself is a company. It's a corporation, has to make money. So one of the major things is they have to showcase value over to their customers. And by being able to showcase how much a campaign that runs on the Trade Desk is going to provide, how much it will cost, and how much it will actually bring in for them, that's extremely valuable. And the more accurate it gets, the more customers trust the Trade Desk as the largest independent DSP platform. We look at things like conversion forecasts, and very importantly, we also look at things like customer lifetime value. These are all components of the ads lakehouse, and we want to actually add another layer that's quite essential to all of this. There is a lot of data coming into this. In the case of those advertisements, we don't have PII, but when we start doing more lifetime values and segmentations, we start getting much closer to those particular trickier parts of data processing that we're going to look at. So we actually need some sort of governance layer. And this is what we call the Unity Catalog governance layer in this case. We're able to work with things like GDPR and CCPA. We have audit logs that allow us to determine how data itself has been read, how data has been processed. We also have our ACL controls to ensure that if there's any relational data, we can actually control who has access to it, not just within the lakehouse, but also outside of the lakehouse. And very importantly for TDD, we start having things like data lineage. Now, some of these features haven't been completely implemented in TDD yet. In the next slide, we're going to talk about what we actually worked with TDD to implement and how that has actually driven value for them. But the point is, once you have these different components of the ads lakehouse, that's great. But ETL itself, generally not really a business. What actually is a business are the products that come out of that. And those would be things like campaign reports, billing reports, your customer 360 reports. And very importantly, where TDD can basically develop a premium for their customers is the recommendations TDD can really provide utilizing their machine learning abilities in order to come up with different ways of actually optimizing different advertisements through ads inventory optimizations, how they can optimize the customer lifecycle itself, and very importantly, how can really optimize campaigns. So we can go from a very high level down to a low level for customers, determine specifically how should they be spending their money in order to get the best bang for their buck when it comes to any advertisement in this space. Now you notice that throughout this entire pipeline, we basically have ingestion, back streaming, we have the actual warehousing itself that is built on top of a lakehouse approach. We have the machine learning framework in this case to actually move data back and forth and very importantly, gather insights from that data. And then we also have what's called a self-service platform. Because as these data products get built out, one of the major concepts we really want to have is you want to have other folks within the trade desk be able to access these data products. They can even help build some of these data products, and they want to be able to do that in a very democratized fashion. Now, the last component here within this architecture you'll notice is what we call data synchronization and feedback. I mean, I believe everybody has all heard the stories about Zillow in this case and the housing market costs. One of the major concepts that we definitely want is when we are building any kind of automated machine learning system, we want to have a feedback system to determine the accuracy of the actual recommendations that were being made. So when we do give these particular reports, billing reports, customer 360 reports, we want to understand, are they missing any information? Generally speaking, that's not going to be the problem. The problems we're going to experience are in the recommendations. Were the recommendations that the trade desk is selling to their customers apt? Did it actually help them? Did we see an increase in conversion? That kind of feedback information can go back into our data sources, and this can be used to further optimize their models. So that's really great. That's like a whole overview of what an ads lakehouse actually is and how we see it operating within a Databricks platform. Let's talk about what we actually built. So the trade desk itself is going to look at a lot of different web pages coming in globally around the world. And what happened is they store these particular web pages within their data lake. Once that data lands into their data lake, they needed to actually convert that into a single language that they could utilize. And from there, they could build a pricing model off of that. So we have two major services that we utilize within this ads lakehouse approach is data lands in the web pages. We then do language detection off of that data to determine what particular region in the world are we looking at, what language are we actually speaking. It's not just important enough to go, I'm located in a particular country. It is possible that country may have multiple languages. We do live in a very multilingual world in this case. So utilizing the language detection methodology and a translation service, we can actually translate these web pages and we can then create vector embeddings out of that. I'm sure you've heard a lot about vector embeddings in the last couple of days, vector databases, Lakehouse IQ, all that stuff. The entire point about this is that when we get those particular vector embeddings, we can now put them into a bidding optimization service known as the real-time bidder, and we combine that with existing data from segments and prices in order to actually build a product that can take feedback and understand how to actually price out advertisements. Now, this particular pipeline, I think, runs daily?
Twice daily.
Twice a day in this case. So what this means is that the trade desk is now able to, twice a day, figure out the actual pricing of web pages for a very good heuristic before they apply a segmentation and pricing off of the real-time model. So that looks great. Everybody loves to see the end product. Everything always looks like, it's all honky-dory in this case, right? Well, there's a lot of optimizations that are made. When you are the trade desk size, in this case, when you are basically the largest independent DSP platform in the world, your main rivals are basically Google, you might need a little bit of TLC in this case to ensure that we can actually build out a model that really fits their needs. The trade desk was translating over 100 million web pages a day. They needed to make sure when they translated this 100 million web pages, they could do it in a timely manner. And they're doing it twice a day. When we originally started this pipeline, it was only once a day. So what we looked at is we were figuring out what possible models could we actually utilize, and how would we actually utilize that on a variety of different platforms. Databricks was actually not the first choice. Databricks became a choice once we realized that we had to scale out this model and we could not do it on a simple single node system. So what Shufu did is that he actually looked at different models that were available. He evaluated their abilities to actually translate web pages. And he saw how fast it could operate within a single node system. And what they found was it wasn't adequate. It wouldn't possibly do it in time. So they began to look at what other resources were available at the time that they could utilize in order to try to speed this process up. That's when they looked at some of our third-party integrations with John Snow Labs. They looked at a model that was commercially available in the Spark NLP models, and they tried that one. Massive boost in speed. Unfortunately, still not fast enough. They needed a bit more in this. They needed to have more speed because remember, this is the entire world's worth of web pages every single day being translated in this case.
Yeah.
So we're talking about 100 million, we will go into billions in this case. So we looked into that and said, the Spark NLP model is working well, but we think we can actually do better. Let's start going into a lower level Spark at this point, since the trade desk has very, very specific needs. So we actually used our pandas UDF systems. So we built a pandas UDF for what's called distributed inferencing, and then we got massive speedups off of that. We're like, this works pretty well. We're getting very high GPU utilization. When we were at the Spark NLP systems, we were at 30% GPU utilization. When we get a naive pandas UDF, we're at least 50 to 60% GPU utilization. And we're like, this is working pretty well. I think we're getting somewhere. But we also have to think about costs in this case. How do we keep the cost of this pipeline down? How do we keep the cost scaling so when the trade desk needs to go into new emerging markets, they don't pay an arm and a leg? So we looked at the actual naive pandas approach, and then we began to think, maybe there are some optimizations we can make on the model itself. And this is where the trade desk actually modified some of the models to make it faster. And maybe there's a way we can control the way the input of data actually goes into the model, basically utilizing batch-based approaches. So we created a mini batching system within the model itself in order to process that data to reduce the amount of round-trip latency for data itself. So we call that the hybrid pandas UDF. Now, we're at very high efficiency. We're about 70% efficiency. We want to squeeze out more percentage out of this because this is the trade desk. There's a lot of data. There's a lot of web pages, and the number of web pages will only go up in this case. So how do we get even farther up into higher efficiency land? We actually optimize that pandas UDF by figuring out not only can we use a mini batch approach, we tune it. Very simply find out what is the best batch number that we're going to operate with. That's called the optimized pandas UDF. At this point, we're about like 80, 90% GPU utilization, extremely high for any kind of NLP system. We're actually translating data very, very quickly. We looked at the holistic pipeline and said, when we started this, we were pretty sure the bottleneck throughout this entire pipeline was going to be the NLP model. And now that we're at this particular stage of our optimized pandas UDF, it was no longer the NLP model anymore. It's extremely fast. It actually was our transformation logic. So some of that data cleaning and the generation of vector embeddings themselves were actually taking a lot more time. So we optimized the transformation process itself. We switched over from some of the, the third-party libraries that are available for that transformation. We implemented more direct native Spark logic in order to really speed that up.
More native, yeah. More basic.
With that particular native system, we finally reached a stage in which we're comfortable. 89% GPU utilization. Can we say how long this pipeline takes?
Right now?
Yeah.
About 1 hour, 2 hours, yeah.
1 to 2 hours in this case. This pipeline takes 1 to 2 hours. That's absolutely amazing. From what I recall, last time was 4 hours, so I think they're speeding things up even more. So that shouldn't be 200 times, like 400 times now. But in this particular engagement, once we saw that we could actually process an entire world's worth of data in 4 hours in a horizontally scalable fashion, we could finally productionalize this. This 200x speedup is actually really important. It's part of everybody's NLP journey. It's part of their customer journey towards actually reaching from, let's say, an out-of-the-box shelf phase, which is going to work very well for a lot of folks, and really squeezing out that performance you want in order to be a company like the Trade Desk.
So what is the results? We went from supporting only 2 languages to 35 languages now. And all these languages are displayed here. So that is the story. That is how Databricks and the TTD worked together and delivered this amazing product. And like Mark said, what works for TTD might not work for your company. But what is really important is that if you do indeed work with Databricks, they have amazing resources, they have amazing engineers. Talk with them, engage your own data scientists, engage your own engineers. Things will work better for you guys.
Absolutely, and one of the huge things about it is we really love our partnership with the Trade Desk. Me and Shuf are actually very good friends.
Yeah.
So one of the huge benefits is not only is it good for the Trade Desk in terms of business and good for Databricks in terms of business, we all both want to grow revenue in this case. But what we're actually doing is we're getting close to that 67% of ad spend that's globally available that's not being tapped. We had between a 10% to a 67% difference right now with the Trade Desk. You can see how now we've actually expanded to all these different countries now. We have 35 different languages that we support. when the trade desk needs to expand into another emerging market, and they absolutely will. They got high hopes and high goals, high ambitions. They needed to have a scalable pipeline that made it very simple to actually add information for a different country. To this day, all this is for them is just changing one small parameter, and their pipeline continues running. In fact, even more, since their pipeline was built specifically on top of the Databricks Spark platform, they can horizontally scale out this platform, so when they have to add, let's say, 20 more languages, if they ever need to expand the amount of resources they have allocated, they can. And since they operate on an elastic compute platform right now within the cloud, that compute is readily available, and they don't have to overpay for compute that they're not using.
Yeah. We recently actually added 5 more languages support, actually. It's just not on the platform yet. Yeah.
So apparently they're up to 40 languages. they might take over for like all advertising for this, I'm not sure.
Yeah.
All right.
All right. Thank you guys so much for coming to this talk.
Thanks for attending.
Feel free to connect on LinkedIn.